GMAT all day!
In the last video, we found how to calculate the area or the circumference of an entire circle. So the area would just be the space within an entire circle, and the circumference would just be the distance all the way around a circle. In this video, we will talk about how to find the area of a portion or a sector of your circle, as well as the circumference of a portion of your circle, also known as an arc length. And in order to find the area of a sector or the length of an arc, you need to know something about central angles and inscribed angles. But before we can talk about either of these two things, you need to know that if you have a circle of any size whatsoever, and you make one full revolution around the entire circle, that is equal to 360 degrees. We will see why this is relevant in a second. Let's talk about central angles. A central angle, if you have a circle with some center, we'll place here, a central angle is just made up of two lines going to the center, so two radii. So for example, this here would be a central angle. Now, every central angle is going to have a corresponding inscribed angle. So let's say the central angle intersects the circle at points M and N. Well, its corresponding inscribed angle will intersect the circle at the same points, M and N, but then instead of going just to the center, it will go all the way to the opposite edge of the circle. I call this the deli counter ticket diagram sometimes, which some of you may or may not get. So this is our central angle here. This is our inscribed angle here. How is our central angle related to our inscribed angle? And you should see that your inscribed angle should always be less than your central angle, just because they're starting in the same place, but your inscribed angle is going all the way to the edge. So you have sort of these two converging lines here. So if your inscribed angle goes all the way to the edge, it should converge more than your central angles, and it should be less. How much less? Well, your inscribed angle should always be half your central angle, or your central angle should always be double your inscribed angle. So if I say my central angle here is equal to x degrees, the corresponding inscribed angle should be 1/2 x degrees. So which of these two angles do you care about? Usually, what you care about is the central angle, because it is the central angle that is going to help you determine the area of your sector or the length of your arc. The inscribed angle, why do you care about that? Well, you care about it because you can use the inscribed angle to get the central angle. Or in some cases, they will just literally ask you to find the inscribed angle, so we'll need to know it in those cases. Now, your central angle here forms this pi wedge shape. This is a sector. It is sort of a portion of your circle. And then our 2 points here, M and N, they also form this arc. And so that is a portion of the circumference, which you can also find. How do you find it? Or I should say, what portion, this is going to be a portion of the area of the circle, or sector area, and then this arc length is going to be a portion of the circumference of the circle. What portion is it going to be? Well, it is determined by the central angle. And so the central angle, x, so as a portion of the circle as a whole, will be x over 360. So our sector area, which is just a portion of the area of the circle as a whole, this will just be x over 360. So that is the portion. Then the area of our circle is just pi r squared. And then our arc length, so in this case, arc length mn, write it like, sometimes you'll see it like this, mn with a little curve over it. This will just be a portion of our circumference around the circle. What portion? Well, it's the same portion here. It's determined by the central angle. Then this will be times 2 pi r. Let's see how now we can apply central angles and inscribed angles in a GMAT question. So data sufficiency question. In the figure shown, the circle with center Q has a radius of 5. What is the area of the shaded region? So our shaded region really looks to be made up of two shaded regions, this pi wedge part, this sector, and then this triangle over here. And so we start by filling in our diagram. And I always, on the GMAT, you cannot write on your screen, so I always take the time to carefully redraw my diagrams so that I can label them clearly. So we have a radius of 5. That means SQ is a radius, so that is equal to 5. TQ is a radius, so that is equal to 5. RQ, don't forget about that. That is also a radius. It's also equal to 5. Now, if they were asking us for the area of our shaded region, and we said before that's really our triangle and our pi wedge, or our sector, we can sort of rephrase this question as we want the area of the triangle RQS, plus the area of sector RQT, I guess you can call it. We need these two things. Now, one thing you do not want to do, and this is one thing they're always going to try and get you to do, is they're going to try and get you with geometry questions. They're going to try to get you to make assumptions based on the diagram that they give you. So for example, if we're looking for the area of this triangle here, RQS, well, how do you find the area of a triangle? A spoiler for our triangle videos, the area of a triangle is 1/2 base times height, which you should know already, I would say. But does that mean that this here, SQ is a base and RQ is a height? Not necessarily, because in order for that to be true, this would have to be a right triangle. And while it looks this could be a right triangle on the GMAT, you cannot assume that things are drawn to scale. So unless it has a little box thing in here, or they tell you that it's a right triangle somewhere, you cannot assume it. And therefore I cannot assume SQ is a base and RQ is its height. And actually, if you did assume that, if you just assume this angle here was 90 degrees, you would be able to answer this question from the prompt, which is one reason you should know that you cannot assume that, because you should never be able to answer a data sufficiency question from the prompt. Because if this was 90 degrees, this here would also be 90 degrees, so you would know this central angle here. And if we know the central angle, we know the radius, so we should be able to get the area of this sector. Then we would also be able to get the base and the height for this triangle, so we'd be able to find the area here, and we would be done. That is obviously not true. This is really as far as we can go. We can sort of just rephrase our question. Angle RQT is twice the measure of angle RST. What is that telling us? This is telling us that RQT here, okay, this is x degrees, is twice the measure of RST. So they're really putting this, say this is x degrees. They're saying this is 2x degrees. So what is this telling you? Well, we already know from the prompt, RQT is a central angle, right? Because it is made up of two radii. So we know it's a central angle. We don't know the measure of that central angle, but we do know that RQT is a central angle. And we also know that RST is its corresponding inscribed angle, because it intersects the circle at the same 2 points, R and T, and then just goes to the opposite edge of the circle. So statement 1, that sort of is telling you the same thing. If this is x, and then this is 2x, well, that's just sort of restating that this here is a central angle, this here is an inscribed angle, and this information is really nothing that you didn't already know from the prompt. So statement 1 here really is not only insufficient, it is irrelevant. It is just repeating information you should have already known from reading the prompt. So you can not only eliminate A and D here, you can really also eliminate C, which sometimes you can do, but only when the information is literally contributing nothing. It is restating information that you have already been given. Now, statement 2 says angle RST measures 45 degrees. So we already know that RQT is a central angle, RST is an inscribed angle. Like we said, we did not know the values of those angles, so we know that RQT is going to be twice RST, but we don't know what this is twice of. Now in statement 2, this is telling us this is 45, therefore our central angle is 90 degrees. This is what you might have wanted to assume from the beginning. Now we know this here is 90 degrees, but RQT and RQS, they form a straight line, so this here is also 90 degrees because they have to add up to 180. So now we know we have a right triangle here. Therefore, SQ is a base. RQ is its height. We want the area of our triangle. That is just 1/2, 5 times 5. 25 over 2. Remember, we cannot say that before. Because even though we knew this was 5 and this was 5, SQ was 5 and RQ was 5, we didn't know that SQ was a base and RQ was its height until we knew that we had a 90-degree angle here. Then the area of sector RQT, we also know, because the RQT is this sector here. And so it's going to be a portion of the area of the circle as a whole. So the circle as a whole will have an area of pi times 5 squared, or 25 pi. What portion of that area is this sector going to be? Well, it's going to be 90 over 360, or central angle over 360. It's just 90 over 360 is just 1 over 4 times 25 pi. This is 25 pi over 4 is the area of our sector. So the area of our shaded region is the sum of those two things. 25 over 2 plus 25 pi over 4. I have no idea what that is, nor do I care. I know it is equal to something. And so statement 2, by itself, despite the fact that statement 1 really told us absolutely nothing, statement 2 ended up being sufficient. So B. Now, if you didn't know anything about central and inscribed angles, you would think that the first statement is telling you something. But if you do know something about central and inscribed angles, you would know that this information could have been determined without this statement.